Hello, and welcome to the final part of our series on developing solutions with Azure Cosmos DB. This section will talk about change feed, analytics, AI and machine learning, and migrations. You'll learn how to drive change feed and analytic solutions, understand the integration points with other Azure components, so that you can enable artificial intelligence and machine learning. And with that, I'll hand it over to our instructor, Shri Ram.
Hi, friends, and welcome to the last part of the three-part series. Thank you for all of you who have been spending time with me on part 1 and part 2, where you have learned what Cosmos DB is and what APIs are available within Cosmos DB. And you have seen the SQL API at a greater depth. We also call it the core API. You have seen how Cosmos is scalable with the construct called partition key within Cosmos. You saw the practices for designing a partition key. You have seen what a change feed is, and you have seen how to ingest telemetry in real time and make your applications much better or much real time-ish. So today, let's switch gears and we talk at greater depth about how you can actually do analytics on top of the Cosmos DB data and how you can do AI on top of those data storage. Having said that, let's jump into today's session. For those of our friends who actually joined the third part directly, I would highly encourage you to go and take the first 2 sessions so that you really appreciate the third session. Nevertheless, if you want to bypass the first 2 sessions and listen to the analytics story on Cosmos, then welcome. So we actually saw that Cosmos DB is a multi-model API database. It has key value databases, column value databases, document databases, and graph databases incorporated as APIs, wherein we call our document API a core API or a SQL API, key value as a table API, column family we offer Cassandra API, and we have a Gremlin-based graph API. Also today we will see what other document APIs are available on Cosmos DB. One is MongoDB. Essentially, if you are a MongoDB customer working on-prem, and if you want to quickly migrate your applications into the cloud, then MongoDB API is going to be your go-to. We saw how speed is guaranteed at any scale, which is partition key, the main construct of the design in the NoSQL database. We also saw how to achieve mission criticalness for your applications by doing multi-read and multi-write regions, which are available with Cosmos DB. And also, we have seen various APIs, SDKs that are available so that it makes your life as a developer very easy utilizing those SDKs. So as far as Cosmos DB is concerned, we also saw it is a fully managed service in terms of compute and in terms of storage. So you can actually scale your data to petabytes, or hundreds of petabytes without worrying about the compute. So with that, today let's switch gears and talk about hybrid transactional and analytical processing, which you know it as HTAP. HTAP is getting the analytics on the transactional systems. In this case, as you have seen during past 2 sessions, we actually ingested large volumes of telemetry data into our transactional systems, and our transactional system contains a construct called container. Within container, we stored every item, every document as an item, which is nothing but a JSON file. And on top of that, you can definitely hook Power BI. You can actually use Jupyter Notebooks. Today, I will show you a little bit about how to use Jupyter Notebooks also when we are in the portal. Um, Beyond that, you can also create analytical storage on top of your existing transactional system. And let's see how that is possible. Let us just take a step back and think about what will happen if we do analytical queries on top of a transactional system. And is it even prudent to do that, right? If there is no other possibility, yes, you can actually, do a compute intensive, let's say, materialized view kind of logic on your transactional system. And of course, as it spans across the partitions, which we said they are like some of them are fan out queries, it will actually consume a lot of RUs. And therefore, analytical workloads by definition sometimes demands access across multiple partitions. And you might need a different storage, such as a columnar storage for the analytical systems to be more efficient. And the transactional systems are not meant for that. And therefore, probably we will be better off with some other system, such as a data warehouse, wherein you can perform an event copy from Cosmos change feed. It is possible, we have seen, and today many of our customers do use change feed along with the function. And last session, you have seen how we can actually trigger a function from a Cosmos change feed. When something happens in Cosmos change feed, function actually has a trigger in the form of Cosmos DB change feed, and the function should be able to implement the business logic on top of that and move the data into the target destination. In this case, it happens to be a SQL data warehouse or Synapse Analytics. Is what we renamed our Azure SQL Data Warehouse as. So as part of Synapse Analytics, you can do lots of transformations to your data, such as joins, aggregations, and whatnot, and you can render the summaries in form of dashboards onto Power BI. This is definitely a possibility, and right now a lot of our customers use this in lieu of HTAP. However, there is something better I want to actually discuss today. Again, this is extract using Data Factory. We have seen Data Factory during the last session, and this is again data movement, which is not efficient based on what we have discussed. So in order to actually do it in a little bit efficient form, what if we have an analytical container right besides the transactional container, wherein the data in the analytical container is stored in a columnar format versus the data stored in the transactional system as a row format? And what if you point your users to read the analytical store, wherein the RUs are consumed much more efficiently for analytical queries without disturbing your transactional system? So in this architecture, the advantages of this architecture is we can actually directly read on top of the analytical store that is part of Cosmos, either from your SQL or from your Spark code. And guess what? Azure Synapse Analytics Workspace have the capability to perform SQL on demand or to spin your own Spark pools and create Spark queries directly on top of the analytical container that is shown here. And you can use the Jupyter notebooks that are part of our Synapse Analytics Workspace that is built on top of Spark engine, and you can run the queries directly on top of the analytical container. And the technology that enables the integration between the analytical store and the Synapse Analytics Workspace is called Azure Synapse Link. So we need to actually enable the Azure Synapse Link so that your Azure Synapse Analytics workspace, Spark application, or SQL on demand application would directly read the data off of Analytical Store, so that you don't need to use any external ETL ELT tool or any other streaming process to move the data from one place to another place. As in this case, you can bind the analytical data store directly onto the Synapse workspace, and you can use it as a backend data store. So the advantages of such an approach is, here you have actually literally zero impact on your operational workloads, since they are mutually independent of each other, the transactional and analytical containers. And RUs wise, analytical store is optimized for columnar based queries, which is pretty much, the aggregations, joins, and all that different kinds of stuff that are performed in our analytical space. And therefore, less number of RUs are consumed. And there is no batch process in the middle, which means your data is available as it comes in, and you don't need to build and maintain any ETL code as part of this process. And of course, the low latency, which is the time it takes for the data to replicate between transactional and analytical store, is very low, right? And therefore, it provides you, this architecture provides you with utmost flexibility, especially when dealing with transactional queries as well as analytical queries, as part of one single database storage, in this case, Cosmos DB storage. So let's take one step back, and what we can do is, definitely as part of this process, we can actually, still utilize the Cosmos change feed, don't get me wrong, and still we can write back into the transactional system. Let's say we create a quick materialized view by utilizing the Azure Synapse link. We can put back the data corresponding to the materialized view into the transactional store. So given that, if we were to write back, the transactional applications here can still get benefited by the data we wrote back. And please refer to the video in session 2, wherein I spoke in detail about how the materialized views that are built on top of the transactional systems reduce the frequently, or the duplicate queries that are run across tens of thousands of end user sessions, and how they can reduce the RUs. So the same thing can be achieved, but in a little different way, um, um, using a different kind of technology, right? The Spark technology that is built within Azure Synapse Analytics. So your app got benefited, your end user queries got benefited, and you are consuming less number of RUs. So this particular architecture is win-win-win for multiple scenarios. So let's actually go ahead and look at our first demo for today, wherein I have this fictitious application wherein we actually report on quality assurance data, and we also utilize cutting edge machine learning to make some real-time decisions in case the quality assurance is affected. So as you can see, we have actually a Cosmos DB database here. So on the portal, I configured a dashboard to see what would be my latency as I monitor my system near real time. So my system, it has 83.5 terabytes of data available in my system. And as you know, we don't index every single field. We have, let's say, indexed 10% of the fields, and therefore my index size is 8 terabytes. And I have 5.2 million RUs assigned for this. As you can see, I have multi-region capabilities enabled here. So my application is global, and it is serving Asia, South America, North America in this. So given this Cosmos DB, let's see how we can actually enable a Synapse link and go from there. So first, let's take a look at our containers and see how exactly our data looks like. Let's go to Data Explorer. Data Explorer, let's go to our supply chain database. Underneath the supply chain database, we have multiple collections. So in this collection, we have multiple items. Let's go and test one of the item and see how the document looks like. It seems to be a plain and simple document wherein you have an ID number, we have the engine number, and it says if the quality assurance test is failed and what exactly is the part. In this case, it happens to be a spark plug, and where is your assembly line, etc., etc. Right? So just a typical manufacturing data looks like. Then let's see how we can actually create a Synapse link wherein an analytical container created on top of, besides this transactional container, wherein I can actually do near real-time analytics using the analytical store and do some cutting edge machine learning on top of that. So like we discussed, let's go ahead and enable a Synapse link first. Once we enable the Synapse link, then it will actually ask us to choose our um, Synapse Analytics workspace. So Synapse Analytics workspace, like I said, have the ability to do SQL on-demand queries or Spark queries. Let's choose our workspace. And with that, we actually have our analytical container spun up uh, right besides the transactional collection, wherein we can use this as our input data set in Synapse Analytics workspace. So let's go to Synapse Analytics workspace. So this is Synapse Analytics workspace. As you see here, this is shop. You can set up your data connections wherein you can actually read your data directly. In our case, our Synapse analytical store that is part of Cosmos DB could be mounted directly, wherein you can perform queries. And then you can do much more in this. You can write notebooks using Spark pools. You can execute those notebooks. You can actually create the data factory pipelines and orchestrate everything as part of this workspace. You can monitor all in a centralized location. And you have the Power BI connectivity where you can quickly create Power BI dashboards. So this is a unified experience our end users get. So let's go and see how our data is mounted as you can see, our data is mounted as a Cosmos DB um, uh, analytical store. And as part of that, sure enough, we have this quality assurance that is stored in the columnar format here. So if you click that, like I said, you can write a new SQL script, which is SQL on demand, or you can create a new notebook on top of this particular data set to do advanced metrics. So let's actually go ahead and see what we can do with this particular thing. So let me actually write a quick script on top of the quality assurance data set we have seen. And as you can see here, so we established a link service. The link service is to Cosmos DB Analytics Store within our region, and the name of that is quality assurance. And I'm selecting the part ID, the test result, and some other things that are needed for me, let's say, to do some analysis. So let me go ahead and run this query. Now I am running this query on top of that. And as you can see here, you get the part ID number, the quality assurance test, and the test time. So now, yeah. So then what we can do next is we can create a Power BI dashboard from here, wherein um, in near real time, as my on top of the query that I have created, I want to see what is the current status. Okay. So in order to do that, let me say I go ahead and refresh this particular dashboard. And sure enough, today I have 16% failure across pretty much, like every location of mine. And, um, this seems to be, like, for example, the 94%, we tagged it in red. And therefore, we need to actually take an action. So based on this, we need to take an action. But in order for us to take the action, first we need actually we need the help from our AI system. So since we are having these many failures from one of our suppliers, we need to find who the next best one is, obviously, given the situation, right? Given the product, given many things. So we need some help from our AI service to figure out what action we need to take under the circumstances. So let's go. And we already have built a machine learning model wherein we consume the machine learning model, we predict, we actually give the data corresponding to the open orders, and then we predict who is the supplier that we need to rely on in order to solve our hard situation currently. So given that, so let me go ahead and run this query. As you can see here, right? So depending upon, the situation, looks like this is a supplier, you know, whom we can get a given product from within the number of delivery days that the machine learning algorithm anticipates. So a couple of key things here. So the Synapse workspace have the ability to write a predict function on the model that we have pre-created, and within that query we can use this model. And once we use this model, we can enrich our SQL on demand query, and we can build even better Power BI dashboards on top of such a result, so that we can take a real-time action. So this is called getting insights from near real-time data. And our architecture enabled this very easily. So as you saw here, we are predicting using a machine learning model. So, but first we need to create a machine learning model, for which I use Azure Machine Learning Studio. And we have a component called driverless AI, which is our automated machine learning. So assume if you are not actually a seasoned data scientist, but you're a citizen data scientist who needs to quickly create an automated machine learning model, you go here, upload your data set, and then you create your model. For example, let's say this is my data, historical data, and I need to figure out what would be my forecast value. And then let me press next. And then select an experiment name. Go and select the experiment name and choose our target column. So in our case, the target column, of course, is forecast delivery days. And then let me choose the training cluster on which this has to run. And then once I choose all of these settings, press next and press finish. So you create the automated machine learning model. And this is the exact model that we consumed here as predicted. So once we have that rich query, what we can do is we can create a cutting edge dashboard such as this with AI infused in this. As you can see here, you can see and do many more details here, as far as, if you want to do backorder analysis, and if you want to see the quality issues in greater detail, you can use your Power BI like this. And guess what? The source for all of this, of course, let's not actually deviate from where we started. we started at Analytical store, which is part of Cosmos, which is another Cosmos container that is part of this database. And we created a Synapse link to enable all the other ensemble. So with that, let's actually jump back to our Cosmos presentation. Um, Azure Cosmos DB analytical store design considerations, right? So some of the considerations that you need to keep in mind is, so don't actually, like create more than 200 properties at any nesting level within a schema. Array types, they should contain a single repeated type, right? And the nesting depth should be under control, as shown here. And then the property names must be unique. Um, so all of these things should be taken into consideration. So there is a rich set of documentation available on HTAP, and I would let you explore that. We will attach some links at the end of this presentation. However, Azure Cosmos DB, SQL Core API, the HTAP is in public preview. We recently announced MongoDB, and we are offering the same capability on Cassandra API in private preview. And also, we made Synapse SQL serverless or SQL on demand is what we call, to utilize this HTAP processing in public preview. So this slide is a little old, so right now it is in public preview. You can definitely go and test out. And obviously, you can utilize it from Spark and do a notebook also. So let's now jump to the second part of our session, which is I will be talking a little bit about what if you have MongoDB today on-prem, and what if you are looking into Cosmos DB and you want to perform a quick lift and shift of MongoDB from on-prem to Cosmos DB Mongo API. Yes, you can do that, but there are certain things you need to keep in mind. Yeah, let's skip table API. Yeah. So as we have seen in MongoDB, we don't provide any special SDK or anything. The only reason is you have the rich set of SDKs available. So I use Mongoose a lot as part of Node.js application, and then we have other official drivers provided by MongoDB, and for different programming languages. The links are provided here. You can go and take a look at them, and you can use the exact same things. And also, if you think that you have actually a very large MongoDB that needs to be lifted and shifted into the cloud, or that you are redesigning your application and you are instead planning to use Mongo API in lieu of your on-prem MongoDB, then please involve our product group so that they can actually assign a program manager to take care of your design or to provide you additional inputs for design considerations. Also, we have various avenues such as global black belts and product group teams who can help you be successful in your journey. MongoDB is very popular, especially with Node.js and Java developers. So some of the key benefits is you don't need to maintain your own shards, just like how you can do partitioning with partition key in SQL API or Core API. You can actually perform automatic sharding here in Cosmos DB Mongo API. You get all the goodness of limitless scale and auto scale, the same exact things you have seen with the SQL API. And the billing mode and all of that is same. You have HTAP capability, and we actually invest in MongoDB, and we continue to invest in MongoDB so that you don't need to worry about hey, if I bring my MongoDB application, what is going to happen, right? So please take advantage as we make this API better and better every single day. So you can actually use the auto scale provisioned output. We have seen that we spoke at a greater depth during our last session of how the auto scaling helps us, and you can use auto scaling even in MongoDB world. However, if you are running on-prem or in any other private data center, it is very tough to achieve this because almost always the scale down is going to be delayed, and you actually have to stick with the higher levels of capacity so that you will be wasting a lot of resources. So with that said, let's go and see our second demo on Mongo. Give me 1 second as I pull this up. Okay. Let's go to our Azure portal. Okay. Let's go to our Azure portal. Portal.azure.com. And in the Azure portal, we go and see a MongoDB. We see a that is built on MongoDB. So let's see it. Okay. I have used a mean framework, a mean app, and I have built a mean app from the code I have taken from GitHub. And as you can see, the code I have taken is I borrowed from Ahmed Haq for Scotch.io. I cloned their code, and what I did is I just changed the few components in the code, such as the connection string information for the database, which of course I pointed to MongoDB connection string, and that's it. So, and I'm using every other open source tool, right? So for example, I'm using here in this case a Google Map, wherein I configured a map API, and I am making use of the API. And during my last session, I asked all my Cosmos friends to identify themselves of where they are using this application. So if I want to, let's say, find the teammates which are within this vicinity, I can go and say, search my teammates, and of course, I got all the teammates within this region. As you can see, I'm able to actually get the teammates that are registered on this particular website, of course, with their fake names during the last class. And there we go. This is the application that is built on the this is the application that is built on MongoDB, Mongo API within Cosmos. So let me show you some of the sample queries that we can use. So this is actually a tool called Robo3T I use, right? So this is an open source tool. My database's name is okay, let me pull this. My database name is Cosmo Mongo API. Let me see if I can make it a little larger. Okay, here we go. And the name of my database is userdb. And here I am actually firing up the queries. So let me take a sample query wherein, for example, I live in Dallas Fort Worth area. So let's see if I can actually query who is near my location, right? Which Cosmos friends are near my location. So what I have done is I have created a quick query that says db.users.find, and the location. As you can see, I'm using the geometry type, which is point, and I have provided my lat long location, and I said I want all those people who are within 50 miles. So let me go and run that, and sure enough, I got all these people who are within 50 miles. So some of them are test data, but some of them are real data. Looks like there are some Python and C# programmers near me who are interested in Cosmos. So likewise, you can actually, for example, let's say I want to write a query on top of the Cosmos DB with Mongo API enabled. I can say find all those users whose age is less than 15. Um, let's see what it gives. Okay, I want those usernames and I want the gender, which is select username and the gender from this table wherein the age is less than 15. So some of the little friends are here, right? So for example, this little friend and these three little friends are near me. And oh no, not near me. In my entire database, I have three little Cosmos friends. So the point is I wanted to show you how we can actually use these open source tools to perform some of the queries. Now let's go back and see what exactly is the Cosmos database I'm using, right? So let me go and I will show you the Mongo API enabled stuff, which is nothing but srram demo MongoDB is my MongoDB. And as sure enough, as you can see, the database is user DB. Let me enlarge this. And I have 10,000 RUs that are provisioned on those. And these are the, this is the collection I have underneath that. So as you can see here, a user, I think I have created it under admin or one of these. Okay, I think I have created underneath the users. So this is the user document you can see here, and this is the location information, right? I am capturing, and sure enough, if you go and see the settings, let me go and documents. Okay. So you could have written the queries. For example, you can type a query right here and use those queries. And you have a similar experience, right? You can do all of that. And even we provide the shell. You can actually fire your queries from the shell too. But anyways, I wanted to show you that this is no different than the SQL API you have seen during our last session. But here the API is Mongo API. So you can actually have the same bells and whistles wherein you can actually do multi-region writes, multi-region reads, and all of those stuff. And you can do all the monitoring tasks that we have been seeing and everything, right? So this is exactly the same experience you get on top of this. So if you want to actually uh, see the code that I have used to build the app, we have included the GitHub repo and app tutorial as part of the material, so that you can go and check out this gentleman's code of how we have just changed the connection string, and you can just play with that connection string. I just changed the connection string, and you had to give the Google Maps API. Those are the only two changes you need to do, and the rest of the stuff is perfectly fine. Also, what I wanted to show you today is I wanted to show you the experience around using notebooks. So let's go to one of our Cosmos DB databases that we have been playing with. So let me open a Cosmos DB SQL APIs database that we have used during our first two sessions. Remember the vehicle data we have been capturing? Yeah, that's the exact same thing. So we go here, and as you can see here, these are the notebooks. So you get actually a rich set of notebooks. And for example, you can go here and say, right, new notebook. Oh, okay. So getting started. So let me go ahead and download some of the sample notebooks. As you can see here, this is how the notebook experience would be. So for example, here you can actually write the same Python code that as a Python developer you would be using, import OS, import time, and import Azure.Cosmos. What exactly is this? This is the library that we provide, Azure.Cosmos library. And you provide actually your database name, your container name, and you can actually create all of these queries. For example, let me go ahead and run few of these, right? So yeah, 1 second. So let's go ahead and run some of, oops, then that. Okay. Now, for example, let's say I run that. And as you can see, when I say select star from a collection where win number, remember last time our partition key is win number. And then we actually created multiple entities within the partition, and the entity type is vehicle. I want to see the vehicle data, and the results are captured like so. And you can run all of these nice queries, right? So you can actually write whatever query you want. You can see the RUs, you can see the metrics, you can see the data within the data frame itself, like shown here, right? So all of these data are coming like this, and you can do all of your analysis from these notebooks itself. This is another experience I wanted to show you, which I think I forgot. I didn't show you last time. You can use Python to do the stuff. So then let's go back um, to our presentation and see some of the queries. So we have seen MongoDB API CRUD operations. One is insert, and the document size differences. There are some of the key things you need to keep in mind before you migrate your on-prem MongoDB application into the Cosmos DB Mongo API. One of the important thing is MongoDB's max doc size is 16 MB, whereas Cosmos is 2 MB. That means we need to remediate this for any reason. If you have more than 2 MB of a document, that means you are dealing with a large document. Now, probable reasons might be you are saving, let's say, an image as an attachment, or you are doing something. So now the idea is, can we actually split those 16 MBs into multiple 2 MBs or smaller files so that we can store images separately from analytical data or from some other data so that we can do analytics, right? So this is one of the things, please keep in mind before you make such a decision. So also, when you actually want an unlimited storage, you got to perform the sharding like shown on the right hand side, right? Remember, like partition key, here we have shard key, and you can even turn on the analytical store. So this is how you do the read operation. We saw the query db.users.find. This is exactly what we have seen. And you can perform updates and deletes. So also you can use Mongo shell. I showed you the Mongo shell. At the Mongo shell, you can write db.call.createIndex, or you can actually specify the time to leave, which is a very cool feature, right? So, and also there are certain features in MongoDB API, such as change streams, right? Change streams is a MongoDB native feature, which is very much similar to Cosmos DB change feed. It is supported on Azure Cosmos DB Mongo API 3.6. So please make sure that you spin up 3.6 in order to perform this. The operation type and update description are not yet supported in this particular feature. This is another thing you keep in mind when you are lifting and shifting. Okay. The insert, update, and replace operations are currently supported. The delete operation we have seen, right? Last time you can set soft deletes and create time to leave. Features in MongoDB API, single field indexes, geospatial indices. Remember, we have queried just 5 minutes back that get me everything within 50 miles radius, and guess what? I have an index on my table, and the index is 2D sphere, the location, right? That's the exact same index I had. So then you can definitely do db.run command, and you can create a database using custom action. You can update database with the new offer. In this case, it's 1200 RUs, right? So these are different commands that I am incorporating on these slides, and you can definitely use them in your practice day to day. So there are actually some common errors that can occur on MongoDB API when you are performing the lift and shift. Some of the key things are exceed time limit, right? The request has exceeded the timeout. Remember, the timeout means in some cases, let's say you're doing an extremely large request, and it needs actually the more number of request units than what are already allocated, and therefore you get this error. So you got to tune your query in some way, mostly like by splitting a large request into smaller ones is one of the things you can do. Also, the total number of request units consumed is more than the provision request unit rate for the collection, right? So you can definitely get throttling. In that case, if you know you will be throttled, then definitely you might need to implement retry logic on some of the things, right? So in the SDK, as part of SDK, if you were to use the native core API or our SQL API, you already have that incorporated in some of the key APIs. But you might need to do it yourself, the retry logic, without which you can definitely get 16500 error. And like so, since this is a multi-tenant service, sometimes you can get exceed memory limit, right? So try to restrict the query, right? So as you try to actually, uh, um, run with large documents, sometimes you get this client memory thing. You can click the link over there that I have provided on this that provides you more information. But the key point is I want to point out some common errors that you might encounter. And the second important thing that most of my customers ask me is, how would I migrate my on-prem data into the cloud first, right? That is something you need to do first. Otherwise, which you cannot do anything. So how do you do that? Actually, we offer something called a data migration tool, which is actually easy to set up. But for smaller data sets, it is okay. But for larger data sets, it is not suitable. Of course, you can use Azure Data Factory. We have seen to move large volumes of data from one location to another location. However, lack of checkpointing in Azure Data Factory, we spoke about it last time, and therefore there is no dead letter queue in that. Also, given these circumstances, yes, you can use, but only if you are 100% sure that just you are moving data from one location to another location and you don't go wrong anywhere, right? Because the last thing you want is you spend 5-6 hours on moving large volumes of data and it fails and you have to redo everything again. And there are some existing Mongo tools such as MongoDump and Mongo Restore, which are pretty much right, very easy to set up. And if you can handle the throttle, you can definitely use these. But one thing which I recommend is Azure Database Migration Service. Azure Database Migration Service is a fully managed migration service. It actually is suitable for large data sets. It takes care of replicating live changes. You can actually perform database migration in two modes, which is one is offline mode and one is online mode. So MongoDB has support to both of these modes. Online mode you can do using premium service, and in online mode the advantage is you don't need to actually stop your on-prem service until you decide to press that one final button that takes your cloud service online. And please remember that online service also needs a little bit of downtime, but it is so small. And of course, offline you can actually do the exact same thing that you do with online migration. But here, your database would be on-prem database would be offline for a little longer. So if you are actually dealing with uh, BSON files, then Mongo Restore, these kind of things are really useful. If actually they are JSONs, you can just stick with whatever other options you have. So some of the pre and post migration considerations, please understand your app configuration, estimate the throughput, choose your key properly, index your data. All of these are nothing new. We all spoke about those. Then post, you change connection strings in your apps. Don't forget those. Optimize the throughput, because managing the throughput, you take all the required precautions, but still you might need to do the last minute optimization, which is unavoidable, and be prepared for that. And you need to optimize your indexes. Remember, you can't index everything. You have to index what is needed. Uh, how do you know what is needed? Your end user query patterns determine what is needed. And also index your data for performance. Choose your geo replication needs. So one of the key thing I want to tell you again is the minimum number of RUs that are allocated to a given that are allocated to a given container is the max of 400, a maximum throughput provisioned divided by 100, or current storage times 10 RUs per GB. And this is the calculation which you need to keep in mind. So for example, if you are using 1 terabyte of storage, then what would be your um, RUs? So the RUs would be 1000 times 10, which is 10,000 RUs per second is the minimum, right? And let's say you scale up to 100,000 RUs per. If you scale up to 100,000 RUs per second for any reason, and then you get 10 partitions from the last session. Remember, and therefore every single physical partition has 1,000 RUs now as the minimum, and that is the minimum. So now I want to do a 1 million RUs per second. But however, my data is not that big. I just have to do 50 GB of data. And each write takes 5 RUs. So each doc is 1 KB, so 50 million documents. So with 1 million RUs, you can do 200,000 writes per second. And my import will be finished in 4 minutes. But wait a second, my minimum RUs is 10,000. So that means now I am left with 100 partitions, right? And when you scale the database down back, because you're just operating with very small data set, you don't need like a million RUs. You went back to 100,000 RUs. Now, since you have 100 partitions, guess what? You will have 100 RUs per physical partition, and the performance sucks. So friends, please mind, one of the very important thing you need to consider is, just because you want performance when loading the data, a small subset, instead of spending 40 minutes, you might be well off to spend 4 minutes by scaling it to 1 million. But when your work is done and you scale back, then you will end up with lot many partitions than needed. And therefore, every single physical partition gets now lot less RUs, and therefore the performance is very bad. Please keep in mind that you don't fall into trap that makes your life a little bit more easier in Mongo world. So the data migration service, real quick, I want to show you a few slides that go through these, and then we'll switch gears to other topic. So this is the experience you get. You have to create a migration service as shown here. The pricing tier, you have to choose it as a premium in order to use online mode, and you choose the number of vCores that are needed. So then You can choose online data migration. As you can see here, the source server type is marked as MongoDB and the target is marked as Cosmos DB. And this is an online migration. So what you can do is when you really start migration, right? So the migration is happening. Then the migration keeps happening. However, the only difference is when you are using the online for offline mode, everything is similar. Okay. But for online mode, what you have to do is you have to manually do finish button. This is when your other database, that is the database you are moving the data from, goes offline. So this is what I was talking about. You get a minimum downtime. So then there is the Cassandra API. There is no SDK because data stacks provide the drivers. There is GoSQL if you're a Golang user. Then Spring Data. Spring is a major Java framework, and a lot of Spring Java developers use Cassandra, and Azure allows Spring. We have the Spring Cloud in Azure, which is the Spring boot service that is maintained, managed by Microsoft. You don't need to take care of any infrastructure. Just put your app, you get your Spring app, run in Azure, connect to Cassandra API on top of Cosmos, and you are good to go. Your existing application is good to go. So with that said, let's spend last 10 minutes talking about Gremlin API, and I will show you probably a demo on the Gremlin API, and then we'll see what you can do as next steps. Gremlin API is a graph API. Gremlin API is based on Apache Tinkerpop graph database standard. It uses Gremlin query language, right? So we actually offer support for that, right? So even our API, you can actually use the Gremlin syntax. So you can actually make a decision to go to Gremlin API if and only if your regular data models don't serve the purpose, right? We will see what are the different use cases that this Gremlin API or the graph database serves, and how you need to be careful not to choose the wrong model for the not to choose the Gremlin model for a wrong purpose. So I'll go in detail. Don't worry about it for now. But for now, you get the same elastic scalable storage and throughput. You get high throughputs from reads and writes, highly concurrent transactional workloads. And again, this is a fully managed platform like any other services you have seen. Familiar graph technology for the transactional applications. So what does Cosmos DB Gremlin API not serve? Which means these are usually the anti-patterns. So if you are actually looking to perform compute intensive, aka analytical kind of queries, please don't use this. Please don't use this for machine learning because this is the wrong thing to choose for doing a data science app. I know what you have been thinking. On the Spark, you have a GraphQL, and you actually might be doing analytics on top of that. But please do know that applications utilizing the Graph API are not same as the analytical applications using a Spark Graph library. So that is exactly what I want to call out. So analytical queries generally tend to be large and complex in the computational nature. And also, please don't assume that lift and shift from Apache Tinkerpop technologies work, right? Every graph implementation is different, and you need to be very, very careful to plan everything properly. Yes, you can lift and shift. However, you need to know what you're doing. Otherwise, just by lifting and shifting might cause some issues. Also, Spark with Synapse, so automatic relationship discovery and resolution. Let's see. Next slides, you will get it more. So I will quickly actually move into, okay, let's talk about the basics, right? So what is a graph? So for those of my friends who are new to this, right? Friends, graph is nothing but you have these different entities, right? For example, the entity can be a person, like they are playing here, right? So all the um, entities could be a person, or a movie, or a user, or an application, or whatever. And however, as you can see here, the graph database contains vertices and edges. The vertices are the ones you are seeing in the middle, and the edges are the lines you are seeing over there, right? So both vertices and edges can have the properties, right, such as identifier and any other properties. For example, person can have property of any age, and then a person, the edge can be a person is friends with another person, right? Friends with is an edge, and the friendship can itself can have different attributes, right? Are they, what kind of friendship is, are they boyfriend girlfriend, or are they childhood friends, or it can be any friendship, right? So likewise, you can extrapolate to any things, right? So I'm mostly talking now about LinkedIn, Facebook kind of scenarios. If you are relating the use case with that, yes, that is true. So that's where graph database would be used, especially the complicated relationships that you are building using all these vertices and edges. So by now, you know what a vertex is, what an edge is. So let's go to next slide. So how can you visualize? You can visualize, for example, let's say you can say that as a simple thing, you can say that, hey, I want actually all the direct reports of, let's say, Shri. Shri has 10 direct reports. I want all the direct reports of Shri. At the same time, I want at least couple of levels up, which means I want to know who Shri's manager is and who is Shri's skip level manager. Yes, fair enough, right? You can write that query and quickly get that information. So these are the typical queries of a graph DB. And I will show you some queries. Don't worry about it. I'll show you some queries in a demo. So the vertex, this is nothing different than we spoke. A vertex will have an ID. It will have a label, right? In this case, the label is a person, and it can have properties, and the edge also will have an ID and a label and its own properties, right? So given this, the graph database as a service um, looks like this. You have an application layer and the graph engine, right? This is how a typical application looks like. And there is an index, and of course, Cosmos partition storage is there in the back. And there are transactional gremlin queries, data modification, DML is one of that. Point lookups, very efficient, right? You can look up Shri and get their attributes depending on some criteria, which are nothing but filters. But there are computational things. What if you want to do traversals? Saying that, hey, you know what, I want to know, I don't want to stop, right? I want to see, I want to go look at Shri and get Shri's entire organization on the top. And also, let's say I want to get each and every individual within um, within Shri's arc. And also, I want to see who each of those individuals are friends with in the entire organization. So that is an example of, like how you are traversing so much, right? It is very computational. So, and same is true with aggregation. So just whatever I told you now, plus I want to see each and every person within Shri's direct reports and their direct reports and count how many friends in total that all of these personnel has. That would be an example of aggregation here, right? So these are all computationally intensive. So these are some of the syntaxes wherein you can say, hey, I want to add a vertex and provide a label to that. And the vertex has all these properties. And I want to create an edge from one vertex to another vertex, right? And the edge can have its own label and of course, its own properties. And you can always modify the properties for either a vertex or an edge. So you can actually explore the adjacency with dot out, and you can say has, right? So for example, from Shri dot out, right? All the relationships that are going away from me, and I want to actually in that relationship, it has somewhere it has a name of Lewis, and you can actually do repeat and until you can use repeat and times you can use. All of these are different ways to traverse. And this is a simple human resources data, right? For example, here there's a sales group, engineering group. For example, these two are entities of type group, right? Or group. And underneath that, there are entities of type personnel. And then you can actually, for example, uh, here Lewis is a member of sales group, right? And Lewis can also be a member of engineering group. Then in that way, then there will be another arrow, right? And another edge. Yeah, this is exactly what I was being. So for example, Andrew belongs to both sales as well as engineering group, right? So if you were to model it in a relational database, it looks like the left-hand side, right? You have this employee and you have this group and you have, these many to many relationships. For example, in this case, Andrew, who is number 3, has 2 different group IDs, right? You see how messy it can become. So this is a very good example of when you need to use a graph in lieu of um, relational data. Reason is, for example, let's say Andrew joined another organization. And in place of Andrew, let's say a new guy came. Let's say Shri came in place of Andrew. All you need to do is you need to just replace Andrew and hook up a new bubble called Shri. And rest of the stuff remains same, right? So keep that in mind. So when rearg happens, the same thing, right? So let's say when a rearg happens, now instead of Andrew, let's say Luce is now the member of both groups. It is simple that now I will point that edge to something else, right? That's it. Versus doing, you see, the left-hand side, I need to do the self joins, which is a little bit complex, right? And the nested groups. So now, if you have these multi-level groups, this even makes more sense. And here you can easily see what you can do, easily deal with subgroups, just like that. And then additional hierarchies. So more than one hierarchical structure, right? What if you have more than one hierarchical structure? For example, there are direct reports and uh, there are actually, like indirect reports. In that case, how would your structure become? It becomes even more complicated, obviously, right? So when you have these very complex structures like shown, graph database make much more sense, because here, as you can simply say, for example, there is this vertex called engineering, which is nothing but engineering group, and dot out, and its members are Andrew and Rima in this case. And in that, I want to actually see, I want to actually see where we have has report as the attribute. In that way, right, you can quickly see um, who the direct reports are, right? So last but not least, all these versioning challenges, right? So as these hierarchies, these relationships change in the relational world, you need to change it in every single place. And all of these tables, they have different versions. You have to let's say, depending upon uh, what strategy you are following for versioning, like You might need to indate the old record and create a brand new record, and it will become very complicated real fast, right? So having said that, which model yields better performance, relational or graph? Maybe that's a wrong question to ask, right? Maybe relational model is efficient over graph model in some cases and vice versa. That's not the point. Just because the same query runs in a little bit efficient way in a relational database, for example, in a SQL server versus a graph, but still think of about all the things. Is it easy for me to capture the version changes in the relational model, to capture the changes in the hierarchies? Think about all of these things. And if that is easy, then maybe graph is more write friendly, and therefore you are sacrificing some of the read performance, which is okay. That's exactly what I'm saying. Performance is not the main advantage, right? It's the usability, it's the patterns. Common patterns when graph data is used. Highly connected data, number one, that's what we have been talking about. These complex relationships, these connections. For example, you have this grocery store, and in the grocery store, let's say you want to actually suggest the alternatives for a given product for a user. For example, if you don't have brown rice, but if you want to instead say you have a different brand of brown rice, or as a substitute white rice, who knows? All these connections, the complex relationships that need to be defined, and if they are highly connected in nature, right, then GraphDB might be an answer. So dynamically changing, right, the objects, connected objects, let's say they have an independent evolution, right? So you have seen that a little bit in the examples I have shown. But let's say you actually, let's take a retail store example. You have all these living store furniture, living room furniture, and for the living room furniture, you can have many different entities like sofas um, and ottomans, and each of them can have different colors. But what if sofas evolve differently from ottomans? In the sense, to begin with, sofas might be available in red color. But because of whatever business decision, ottoman is still available in red color, but sofa is not available in red color anymore, but it is available more in a crimson red color. So that is an example of, though the objects are connected, maybe the sofa and ottoman are connected to each other because they go well with each other, but still they can evolve differently in perspective with their connected relationships. So, and also the high throughput of new relationships, right? So for example, graph data, it shines, you have this vertex and you have all these relationships going from that vertex. Let's say if I were to store all of them on a single physical partition, then when you query that particular, um, you query that particular scenario, you obviously get high throughput, right? So this is an example of highly connected data. A person, he owns a car, he owns an insurance policy, and what if a car shares location between itself? Sorry, what if the two cars that this person owns share the location? Um, the dynamically changing connected entities, my ottoman sofa example, right? So yeah, this is one way to look at it. I'll let you look at it later. And then the high throughput relations, right? For example, the person owns a car, they own a insurance policy. This person owns two cars and they have the policy. But here is the nuance. There is a relationship between the person to person, right? This is a high throughput relation. So for example, what if I store this person and all the relationships and this person and all these relationships in a same place, right? You get high throughput. Some of the anti-patterns: don't use graph for dimensional data modeling, please, because if it is just describing the sets, supersets, they are more relational, parent-child relationships. They're not graph relationships. Likewise, a static single link data, if the relationships barely change, they don't evolve at all, right? That is relational, not this. Expanded relationships to minimize data volume. Um, you know, just because you want to store something in a compact way, that does not mean that you have a graph use case. Yes, you might get a good write, but your read performance might suck, right? Common anti-patterns, these are some anti-patterns, right? For example, if you're trying to establish a relationship between country, continent, and planet Earth for a city, that's an anti-pattern. So the dimensional data modeling, for example, if you have these set of support tickets and, let's say you have the support ticket, right, for a given employee within your organization. And there are line items corresponding to those support tickets. They are ticket 1, ticket 2, ticket 3. This is a dimensional data model. This is like an order and order line, right? Why would we do that in the graph? So then there is this expanded relationship to minimize data volume, right? So for example, if you want to actually, ticket A references to another ticket and, all of these things, expanded relationships, this is just equal to this, is it not? So please evaluate model. Please use the guidelines, right? That I have gone through a little bit. Evaluate your partitioning strategy. Very important. This is no different. And evaluate query complexity. Actually, we provide something called execution profile, and actually that lets you evaluate your query complexity. And now let's wrap this session up with a very quick graph demo. So I created in graph database a very simple one. And this is like a HR kind of data, a very simple data set, nothing much. So if I were to execute it, right, I actually get something like this, a very simple one, right? A very simple stuff like that. So let me show you some of the queries. So for example, let's say I want to actually find shortest path from Emily to John here. So let's see how we can actually write that. Okay, so I'm saying I know Emily is use 006 and John is use 001 or vice versa, right? You actually want to find the shortest distance between these two people, right? And this is how I answer, and you can see the request chart just like always. And also, we spoke about the query complexity, right? So you can actually see it like this. This is an example of, I told you how you can actually, so you can see this one, the execution profile. This is what is. So it'll show you what is the complexity of your query, right? In this nice format. And you can definitely assess, hey, how complex is my query? And therefore, what exactly I can do. So this is some neat trick that you can use. And you can actually, use many other queries, the Gremlin API kind of stuff. So with that, I think we are at the time for today to just wrap our session up. And first and foremost, I want to thank all of you for attending this 3-part session, 1.5-hour sessions. This is actually, it is an honor for me to talk about Cosmos with you friends, so that you can implement it in your organizations. However, you can I'm available on LinkedIn. You can reach me on LinkedIn. And also, last but not least, there is this Microsoft Learn, and in Microsoft Learn, you can actually do work with NoSQL data in Azure Cosmos DB. You have all the exercises here. We attach all the materials that we have covered in the last 3 sessions, and you can practice everything I have shown yourself. And hopefully, in next few weeks, you will be the Cosmos experts, and you will start implementing this wonderful NoSQL technology in your organization using various APIs. Thank you all, and goodbye until I talk to you again.